Hi, I'm Marty. Hope you're having fun. Today, I need your help. I want to be able to solve a problem. Wait, not just any problem. It's a problem that requires a computer to see. Wow, just like a human. But before we get in any design process, I want to share some cool tools that I think you'll find really interesting, and they'll take us into the world of AI, artificial intelligence. At different points along the way, you can pause this video and that's a good way of learning. You can try some of these tools out and build on your knowledge. And finally, once we've done that, we'll go to the design process, and then I'll pose a problem and try and apply our understanding of an AI that can see. So the first question is, how can a computer see?
So let's think about a computer that can see. So to be able to see, it would need some way to look around its surroundings, and then the trick would be to work out what it's seeing. So I'm going to flip my camera around and show you what I can see. Here's my phone camera flipped around. So it's able to see using the camera as the input, and it's collecting data. In this case, it's moving images and recording them. But the camera doesn't recognize what it sees, it's just recording. So how does a computer, if it's going to be smart, how does it recognize what it sees? And that's where we're going to talk about computer vision.
What is computer vision? Well, it turns out providing the actual image as digital data, that's the easy bit. For a computer to understand what is in the photo, that's the challenge. With computer vision, the AI can predict what objects are in the photograph and where they're located. And to do this, the computer learns with lots and lots of data, training data. So we provide images of many different types of frogs, different sizes, different colors, in different positions and different backgrounds. And together it puts up a picture of what the frog is. And we have thousands and thousands of images to do that. And this process we call machine learning. So imagine we wanted to use machine learning to work out the difference between a kangaroo and a rabbit. Again, we give the AI lots and lots of images, and the computer looks for patterns in the data to build up an algorithm for a kangaroo and for a rabbit. So looking at the kangaroo, it may work out that the kangaroo has a large body, a long tail, short ears, short arms, and long legs. And if it looks at a rabbit, it might see that rabbit as having long ears, 4 legs, a small body, and a small tail. So we can do the similar thing here like the computer does. We can put basic shapes together to represent an object. So see if you can work out what this is. Any ideas so far? Looks like a bit like a horse, someone says. Could be right. It does look like a horse. Oh, this is a bit of a clue now. Yep, I think you're getting it. See how we're using the shapes to represent that object? And I bet you can guess it's a kangaroo. So I've animated that, but what I might do is give you a task, have a chance to have a break. If you want to stop the video, try this and create your own animal out of, or another object if you like, out of 2D shapes. Pause the video and give it a go. How did you go with that? If you did that challenge, or you want to do it later, it's using computational thinking. So what you had to do is break down the problem, work out what the task was, think about what the important information was. So what were the features of the kangaroo or whatever object you chose to put into the patterns, into the shape. You looked for the patterns that made sense so someone else could work out what that animal was. You created a series of steps to solve the problem, and you created a model, and then if you gave it to a partner, you could work out how well it worked. So well done. All right, here's one of those cool tools I mentioned at the start. let's test how an AI uses computer vision. So this is Google's Vision AI. And what you're looking for is this little application here. It says try the API. It's built on machine learning, which I mentioned earlier, how it works. It'll ask you to select an image. So I'm going to use this one. And it'll, on the first try, it'll say, am I a robot? No, I'm not. So it's just a way to check whether you're not a robot doing something silly. And have a look what it's done. It's recognized the two faces. Let's focus on the first one, the baby. And it actually says some of the emotions that it might come up. So the reason why I'm showing you this is I don't want you to use any of your personal images. I don't want you to use any faces of people that you might know. Now the reason is because we don't really know what the AI does with those images. It might store them and use them for other purposes. So we don't want that. So we need to be very careful when we're on the internet. Don't put any images of ourselves up that we don't know what's going to happen to them. So better be safe. Anyway, let's get on to how this works. So you can see how the AI has labeled the faces. Let's try our animals. So let's start off with our friend the kangaroo. Can it work out what a kangaroo is? What's your bet? Do you think it can? Let's have a look. And it's 80% sure it's a kangaroo. Okay, let's try something else. What about the elephant? I'm sure it'll know what the elephant is, but what do you predict? How well do you think it'll understand or recognize what the image is? 97%. So interesting, isn't it? Doing well so far. Let's give them something tricky. And I'm going to give it an emu. Do you think it'll know what an emu is? Let's have a look. It's thinking. It's thinking. It's called an ostrich, and the baby's also ostriches. Can you think why it's got confused between an emu and an ostrich? If you think back about how maybe it was trained with the data, do you think it was trained with lots of information from Australian animals or mainly from around the world? Let's have a think about that. So maybe it didn't have a picture of an emu when it was trained. Quite simply, let's try one more. Let's try this. Everyone knows it's a bird. It doesn't know it's a kookaburra, and that's another thing. Notice how it just says it's the type of animal it is. It won't tell you it's a kookaburra or a swan or something a bit more focused or specific. So it hasn't been trained on that, but works pretty well. So what I'd like you to do is have a go yourself. Try the AI, Google's AI. Remember to use it safely and see how you go. It's a great. All right, you've now had a brief introduction into computer vision and machine learning. So now I want to use that to solve a problem. And I'm going to show you one example, and it's a strain example. And the problem it's trying to solve is how do we protect swimmers and surfers from shark attack? Okay. In our problem protecting the swimmers and surfers at the beach from sharks, what are some questions that we really need to consider? Can we train a computer to recognize the shark in the water? What data would we need to train the computer? And what are some of the challenges involved? And how do we get the computer to view the water and look out for sharks? Well, this solution used a drone, and you can see the drone's carrying an inbuilt camera and using that to view the water surface. And it can recognize the shark, but also the dolphins. So if it recognized the shark, it would send a message to the lifeguard, and then the lifeguard could warn the beachgoers. Oh, if it was a dolphin, everyone relax, nothing to worry about. How about solving your own problem? So let's define the problem first. What problem do you want to solve and how you might come about that? is when we ideate, come up with some solutions, brainstorm, make a sketch, use a mind map. Come up with more than one solution though. That way you can work with some other people to refine that idea. And then we can use pitch planning to take that one idea that people in your group agree to and present that to another group to refine and hopefully go to the next stage. So apply your thinking about machine learning and computer vision, and I hope you have a lot of fun with this activity, because I think it's great when you innovate and you trying to invent some new ideas. So good luck with it. I hope you had fun today. I certainly enjoyed sharing some of the ideas about AI. I think it's a wonderful topic and exciting topic to find more about. So good luck. Now, if you want some more of these conferences, keep your eye open for next year. It takes the Spark conference and the YES conferences. Get involved. Hopefully we can do it face to face next time. All right, thanks a lot.